Before sawmills, pressure-treated lumber and kiln drying, medieval carpenters had to get creative. They worked with trees full of moisture, unpredictable grain, and natural weakness. Yet somehow, the beams in Europe's oldest barns, churches and bridges have survived for centuries without splitting under load. For the next minute, stay with me, because one quiet technique, rarely discussed outside niche historical carpentry circles, played a much bigger role than most documentaries ever mention. It wasn't a special tree species, it wasn't magic resin, and it wasn't brute craftsmanship alone. It was a method carpenters used to compress, discipline, and strengthen freshly cut timber long before iron nails or factory presses existed. This technique shaped the durability of medieval structures, but it was intentionally undertaught, handed down only through guild apprenticeships. And once you understand how it worked, you see medieval woodcraft in an entirely new way. Medieval carpenters knew that freshly sawn wood was at its weakest. Moisture inside the planks made them prone to warping, cupping, and splitting as they dried. Instead of allowing this to happen naturally, they intervened. They pressed the planks under controlled, even pressure as they dried. Early wood presses were simple. 2 heavy beams, 2 upright frames, and a system of threaded wooden screws or wedges. The planks were stacked in between these beams while they were still green. As the wood dried, the pressure forced the fibres to compress rather than expand outward. This controlled compression pushed moisture out gradually and aligned the wood fibres, making the final plank denser and far more stable. Archaeological finds from medieval workshops in Scandinavia, Germany and England show remnants of these wooden screw press mechanisms, proving that the technology was far more advanced than many assume. It was adapted from wine and oil presses, which were already common in farming communities. Over time, carpenters refined the technique for structural lumber, creating beams that resisted twist and cracking even under heavy medieval loads. Most people don't realize how wood behaves internally. As planks dry naturally, the surface dries faster than the core, causing tension. Medieval carpenters countered this by using pressure to keep planks flat and fibre aligned. The press forced the plank surface and core to dry at closer rates, reducing the stress difference. At the same time, the compression locked the fibres together so tightly that the final wood resembled slow-growth timber, even if the original tree grew quickly. Guild records from Flanders even mention that press planks were reserved for high-stress tasks like anchor beams, floor joists, shield boards and ship strakes. Pressed boards absorbed shock, better bent more predictably, and didn't explode under tension like unpressed lumber could. That reliability made them essential in construction, where failure meant collapse or injury. Wood movement was, well, really the enemy in medieval architecture. Builders, wanted planks that stayed true as they aged. Pressing solved this. By the time a plank finished drying under a press, it had been denied the opportunity to twist or cup. The carpenters didn't rush this either. Depending on thickness, they left wood under compression for weeks or even months. The result was a plank that retained its shape for decades. Timber-framed houses and halls built with such boards show straighter lines and fewer signs of warping. This technique also allowed medieval builders to meet strict guild standards for uniformity, which is why, structures like the barns in England's Cotswolds or the timber halls of Denmark still stand firm centuries later. Even today, the principle is surprisingly useful, especially for off-grid builders or anyone working with fresh logs. If you cut your own lumber with an Alaskan mill or chainsaw mill, you can replicate the medieval method using simple materials. A basic setup involves 2 strong beams, 4 posts, and large threaded rods with nuts. After cutting boards from a freshly felled tree, stack them between the beams with small spaces for airflow. Tighten the rods gradually, creating firm but not crushing pressure. In the first week, tighten the press a little each day as the wood shrinks. After that, adjust it every few days until the planks stabilize. With patience, you'll end up with denser boards that resist warping far better than boards left to dry freely. Survivalists working with timber for cabins, sheds, or tool handles can benefit immensely from this. Not only does it create more reliable lumber, but it extends the usable lifespan of wood in harsh climates. Another practical application is restoring warped boards. A modified press, combined with gentle heat and moisture, can gradually straighten older lumber. This echoes the medieval method used by shield makers to create curved but stable boards for combat. Understanding how compression and moisture interact really gives modern builders an edge in maintaining wooden equipment and structures. When we study medieval buildings, it's easy to focus on ornate carvings or massive beams, but honestly, the behind-the-scenes techniques like wood pressing reveal just how sophisticated guild knowledge truly was. Carpenters didn't rely solely on the tree's natural quality. They engineered improvements with deliberate processes. That is why structures from the 13th century remain solid, while, some modern constructions fail within decades. The wood press technique reflects a mindset rooted in observation, patience, and deep material understanding. It wasn't romanticized or ceremonial. It was practical, efficient, and critical for survival in regions where homes, tools, wagons, and ships had to endure constant stress. If you want more overlooked insights from the early world, techniques, tools, and forgotten ingenuity, subscribe to In the Beginning, share this video with fellow history enthusiasts, and help keep these ancient skills alive for the next generation.